Okay, so get this. We're diving into something really mind-bending today.
Yeah.
You know how you're fascinated by AI, the human brain, and maybe even digital immortality? Well, this deep dive is going to explore all of that, head on.
I love it.
We're taking a deep dive into this article from Entropy by Tucker and Liu, all about, it's called Personal Neuromorphic Emulation,
Okay.
PNE for short. Basically, creating a digital copy of your mind.
Now, what makes this paper so intriguing is that it doesn't just throw out, like, a sci-fi concept.
Right.
It grounds PNE in some pretty solid scientific principles. The authors argue that both our brains and the most advanced AI, rely on something called distributed representation.
Yeah, I was reading about that. It means that memories aren't stored in individual brain cells like little files.
Right.
But rather spread across a whole network of connections. And get this, it's the same way AI systems store information.
Yeah.
So whether it's you remembering your first bike ride or a computer learning to beat a grandmaster at chess, it's all about those connections.
Exactly. And this shared principle is key because it suggests that the way our brains learn and process information might not be unique to biological matter. This opens up the mind-blowing possibility of transferring that learning to a non-biological brain, a silicon brain, if you will.
Okay, now things start to feel like we stepped into a science fiction movie, but the authors go even deeper, suggesting that the key to capturing the essence of your mind, that unique you-ness, might lie in sleep.
Specifically, they point to the later stages of REM sleep,
Okay.
where our brains consolidate our most fundamental memories, those deeply rooted memories from childhood that shape our personalities, our worldview, even the ones we don't consciously remember.
Right.
Imagine a super high-definition EEG recording your brainwaves during these crucial sleep stages. That's the kind of data they're talking about to achieve PNE.
So it's not just about copying the data of your memories, but somehow capturing the feeling, the emotional weight of them.
That's right. The authors call this the affective charge of experience, and they believe it originates from the limbic system, that ancient part of our brain that drives emotions, motivations, even our gut feelings.
Wait, so are we talking about replicating the whole brain here?
Well,
Even the parts we basically share with lizards?
the authors argue that to truly capture the essence of you can't just focus on the neocortex.
Right.
The part of the brain responsible for higher-level thinking. You need to understand how it interacts with those deeper, older brain regions. Think of it this way. The limbic system provides the emotional color, the personal meaning that makes your experience unique.
Okay. Now, this is where my mind starts to spin a little. Are they suggesting that a digital copy of your mind could actually feel emotions?
Well, that's one of the big questions the authors raise. They don't claim to have all the answers, but they do suggest that it might be possible to recreate the conditions that give rise to emotions in a silicon brain.
Wow, that's heavy. So it wouldn't just be a copy of your thoughts and memories, but also your feelings, your motivations, even your instincts.
Uh-huh.
Are we talking about building a digital soul here?
That's certainly a question worth pondering, and it highlights the fact that PNE is about so much more than just data transfer.
Right.
It's about understanding the entire symphony of the mind, the interplay between thought, emotion, and those primal instincts we often take for granted.
Okay, so we're talking about a digital version of you that could theoretically think like you, feel like you, maybe even dream like you.
Right.
This is huge EE. But I have to ask, how on earth would we even begin to capture all that complexity?
Well, that's where things get even more fascinating. The authors suggest that advancements in technology like high-definition EEG might be the key to unlocking the secrets of the brain. It's like having a super-sensitive microphone that can eavesdrop on the electrical chatter of billions of neurons firing in your brain.
So imagine being able to listen in on the symphony of your own mind, to decipher the code of your thoughts, emotions, and memories. It's mind-blowing.
It truly is. And what's even more incredible is that the authors suggest this might just be the beginning. They believe that the tools and techniques needed to achieve PNE are within reach, and that the next few decades could see incredible breakthroughs in this field.
Wow. I'm already feeling like my brain is working overtime trying to wrap my head around all this, but there's one big question that keeps popping up in my mind.
And what's that?
Well, if we can potentially create digital copies of ourselves, copies that can think and feel, where does that leave the original?
Oh.
What happens to the biological you in a world where your digital self can essentially live forever?
Now that's a question that takes us beyond the realm of science and into the territory of philosophy and ethics.
And that's exactly where we need to go next. Because as mind-blowing as the science of PNE is, the implications of it are even more profound. We're talking about potentially redefining what it means to be human, to be alive, to even die.
Precisely. And that's why it's crucial to have these conversations now, before this technology fully arrives.
Right.
We need to carefully consider the ethical and philosophical implications of PNE to ensure that it's used responsibly and for the betterment of humanity.
Well, that's a perfect segue to part 2 of our deep dive, where we'll be exploring those very questions. So get ready to delve into the ethics and philosophical quandaries of personal neuromorphic emulation.